Hello everyone, welcome back to my channel. In today's video, we'll solve an important problem from chemical process calculation, the heat capacity integration for a synthetic thermal fluid called ThermoX. We'll calculate how much heat is required to raise its temperature using both the exact integration method and mean CP method, and then compare the result using Python in Google Colab. Now here is the problem statement. A heat transfer fluid named Thermox flows through an indirect fire heater. Its temperature increases from 420 Kelvin to 560 Kelvin. The heat capacity of the fluid varies with temperature and is given by this equation: Cp of T equals 1.85 plus 0.2015 times T in kilojoules per kilogram per Kelvin. We need to calculate heat supplied per kilogram of fluid using two different methods. One exact integration and another is mean CP method, and then find the percentage error between them. So let's start with the first method, the exact integration. Here is the step-by-step solution. The total heat added is the integral of Cp with respect to temperature mathematically. So here Q equals the integral from T1 to T2 of 1.85 plus 0.0015 T of dt. When we integrate this expression, we get Q equals 1.85 times T2 minus T1 plus 0.0015 times 1 half of T2 squared minus T1 squared in kilojoule per kg. And mean CP method, Cp is equal to Cp of 420 plus Cp of 560 by 2, and Q mean is Cp average mean T2 minus T1, and we can calculate percentage error. So that is percentage error means Q mean minus Q by Q into 100%. Now let's jump to the Python to verify the result. We define T1 and T2 as 420 and 560 Kelvin, and here that A and B, so that is 1.85 and 0.0015, that is the coefficient. So in that equation CPT of A plus BT. Now Q exact we can calculate, so that A into T2 minus T1 plus that we got in that here, and then Cp 420, so that is we will get from Cp 420, that is already given, or we can also calculate from that. Cp 420 that is given 2.48 kilojoule, and Cp 560 that is also given. Okay, so from here we can easily calculate Cp mean, and then we can also calculate Q mean, and percentage error is Q mean minus Q exact divided by Q exact into 100. So now if I do the calculation, the Python could perform the integration automatically and prints out the result. It calculates the exact heat added is 361.9 kilojoule per kilogram, and then we use mean Cp method for comparison. We take already, we know the Cp is at 420 Kelvin is 2.48, Cp at 560 Kelvin is 2.69, and find their average and multiply it by temperature difference. So that gives some same answer, 361.9 kilojoule per kilogram. So now here Python will calculate that percentage error. So here 0% error we are getting. So that confirm that mean Cp approximation works perfectly in this range. So what does this mean physically? So it means that for a small temperature range or linear Cp variation, the mean heat capacity method is just as accurate as direct integration. But for large temperature range or nonlinear Cp equation, you should always use the integral method for better accuracy. Now to summarize, we have learned how to integrate variable heat capacity with respect to temperature, verified the result using Python, and compare it with mean CP method. So if you found this is helpful, give the video a thumbs up, subscribe to my channel. Thanks for watching, and I'll see you in the next video.